take baby steps. We start with the unit circle. Unit circle. Circle. With center at the origin. With radius equal to 1. Does anybody remember an equation for a circle with a center at 0, 0 that has a radius of 1? Oh, sad day. You remember the equation for a circle? X squared plus y squared equals r squared. Remember that? Tyler did? Just didn't want to say it. Okay. All right. It's okay, Tyler. If you notice, x squared plus y squared equals r squared is very similar to what famous theorem that we know? A squared plus b squared equals c squared, which is the Pythagorean Theorem, which is a way that we solve for right triangles, and triangles are the basis for trigonometry. So there's no surprise that when we first start out, we start really with a form of the Pythagorean Theorem set equal to 1. And it actually forms for us the unit circle, and we use triangles to determine really everything we need to know. It's really quite cool. There's points that lie in the unit circle. And it says confirm that this point, square root of 3 over 2, and negative 1/2 is on the unit circle. How would I do that? Just plug it in. So this is our x value. This is our y value. And we're going to actually plug that in. So the square root of 3 over 2, quantity squared, plus negative 1 over 2 quantity squared. Let's see what that is. What's the square root of 3 over 2 squared? 3 over 4. Good job, Anna Anderson. I used to see your name on all sorts of lists because it's generally first. I was so excited to one day meet the Anna Anderson. Now I, not that it gets old each day, but. You know. What's negative 1/2 squared? 1/4. And so, remember you square the top, square the bottom, and if you square any real number, it's going to be positive. So 3/4 plus 1/4 is 1. So we've confirmed that it is on the unit circle. If you square both values and add it together and you get 1, it's on the unit circle. If you don't get 1, it's not on the unit circle. It's on some other circle. The double unit circle. Whatever you want to make. Make up your own math, okay? All right, so let's change it now. Let's suppose that point P lies in the third quadrant. The point P, and it has an x value and it has a y value. And it says it lies in the third quadrant. And the x coordinate is negative 2/5. Find point P. Well, x is negative 2/5. I now need to find the y value. If it lies on the unit circle, yeah, you just solve it equal to 1. So we can set this up. Negative 2/5 squared plus y squared equals 1. That equation tells us that 4 over 25 plus y squared is equal to 1. See, 1 would be 25 over 25, right? So we can subtract and get y squared is equal to 21 over 25. Now, when we take the square root of y, we get a positive and a negative. Y equals the square root of 21 over 5. positive and negative. You tell me, am I concerned about the positive solution here or the negative one? Which quadrant am I working in? Third. Is x positive or negative in the third quadrant? Negative. Is y positive or negative in the third quadrant? You don't know where your quadrants are. First hour said the same thing. They needed a reminder of their quadrants. Quadrants are very, very important in trigonometry. First, second, third, fourth. So you can see that in the third quadrant, they are both negative. So therefore, you're concerned about the negative solution. So it's negative square root of 21 over 5. That would be point P. Any questions? If they said second quadrant, y is positive in the second quadrant, isn't it? So then you'd use the positive one. And that'll be a reoccurring theme. We'll do that a lot in this class where we have to determine which quadrant we're working in. So if I gave you points, could you determine the quadrants? Could you determine if they were a point on the unit circle? All right, you got the first problem on your test. Way to go. All right, now we move on to something else. Some of these points that lie on the unit circle are extremely interesting and useful. For example, this point that lies at a 30-degree angle to the origin is very, very interesting. Now, Anna looks at it and she says that she knows the other angle. What's the other angle? 60. So this is a 30, 60, 90 triangle. Now again, if we have triangles, we can always use the Pythagorean Theorem. As you notice, this unit circle is developed from the Pythagorean Theorem. If I take x squared and I add it to y squared, I will get my radius squared. We already know the radius squared, don't we? What is it? All right. So what I want to try to accomplish right now is I want to figure out if I have a 30-degree angle, what would the coordinate be on the unit circle? And I'm going to determine that location. Well, if I could solve for these lengths of the triangle, I would know that coordinate, right? Well, a 30, 60, 90 triangle is just half of a 60, 60, 60 triangle, right? Isn't it just half of that? And in a 60, 60, 60, everything's the same. 1, 1, and 1. So if I slice it right down the middle, what will this side over here be? A half. Good question. The curve does not measure a half. It would be that length right there. So then I'm wondering the other length right here. Do you remember the relationship between sides of a 30, 60, 90 triangle? Don't worry, they didn't in the other class either. So you got to write this down somewhere. This is, you're going to want to use this, trust me. Yes, lots of geometry and trigonometry. Anywhere you want. If you have a 30, 60, 90 triangle and the shortest side is x, then the longest side is 2 times x. And the other side would be the square root of 3 times x. Now, given the 2, you could just use the Pythagorean Theorem. But trust me, if we use the Pythagorean Theorem, we'd come out with square root of 3 times x. That's what we'd come out with. If you have, there's another special triangle. Do you know that triangle? an isosceles right triangle, that makes a 45, 45, 90. If this is x, and if this is x, do you remember the relationship between the side and the hypotenuse? Very good. Square root of 2 times x. You need to remember that. That's on your ACT. That's something that will always be referred to in your math courses. That's a relationship you have to keep up here. Okay, so let's go back to our drawing again. So if I have the shortest side being 1/2, what do I multiply it by to get the other side? Square root of 3. So 1/2 times the square root of 3 would be the square root of 3 over 2. So if I want to locate my coordinate, my point, what's the x value going to be then? Square root of 3 over 2. What's the y value going to be? 1/2. We're going to transfer those values over to the other side. Flip it over. 30 degrees. Square root of 3 over 2. And 1/2. You don't know what radians are yet. You'll learn that in a while. Let's do the one for 0. That one will be easy. Stop it. What if I have a 0-degree angle? What coordinate is that on the unit circle? 1, 0. Let's do a 45-degree angle now. Can I erase this, please? Thank you. This one, this is the unit circle, and that means that the radius of the circle is 1. Always. Okay. 45, 45, 90. I would try to sketch this in somewhere right on it as well. You don't have to. You don't have to fill out any notes if you don't want to. I would. $45. $45. There's an XY coordinate, right? Riz, are you doing it in the second quadrant? Okay. Just make sure your x and y values, they might be negative. And that's okay. That's okay. So you would have a negative x value, then a positive y value. So to save space, Riz is doing it over here. But if she sketches it over here, then she's got a negative x value, right? Okay. So let's do this one real quick, and then you'll start to see. We don't have to do them all. You start to see a big relationship that exists. So 45, 45, 90. Tell me, what is this length right here? 1. How do I find the other sides? Divide by the square root of 2. So 1 over the square root of 2. I can't have square root on the bottom, so I have square root of 2 over 2. And the other side will be the same, right? Square root of 2 over 2. So my x and y values are square root of 2 over 2 and square root of 2 over 2, right? Okay, let's transfer it over to the other side. 60, 60, 60. $60. What's my other angle then? 30. Oh, what kind of triangle do we have? 30, 60, 90. What is this length right here? 1. What's the shortest length? 1/2. What is the tall? This length right here? Square 3/2. Nope. What changes? The x and y values change, right? So what's the x coordinate now? 1/2. And the y coordinate? Square 3/2. So you see how they switch, right? Ah, now we see patterns developing. Whoop. How about a 90 straight up? Zero, 1. Oh, look. The x and y values switched again. Let's do one more, and then you're going to fill out the rest of the table on your own. No assignment tonight. Very important, the base of the triangle is always on the x-axis. The base of the triangle is always on the x-axis. Always, 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 always. Never on the y-axis. Never. Whoop. Isn't this very similar to the last one that we did? So what we have here is x, and we have y, and what is the length of the radius again? 1. What's going to be the shortest side? 1/2, but we give it negative value. Why? Yeah, I'm over on this side. I'm in the second quadrant. And since we're on the coordinate plane, the x and y axis, I would then call this a negative 1/2 as opposed to a positive 1/2. And then this would have, what would this length be? Square 3/2. You notice it's not negative because you're going up. Whereas if you went down, it would be negative. So this coordinate is going to be negative 1/2 square root of 3/2. That's the coordinate for this 60-degree triangle. Now you say, Mr. Gantz, why did you just make a 60-degree triangle? We already did 60. No, 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 no. Look, we did 30, right? Then we did 45. Then we did 60. Then we did 90. Now we went 120. So we made that angle. So 120-degree angle, you can see that part of it forms a 30, 60, 90. So I can use that to still find that spot. So let's write that one down. A 120 degrees we had was negative 1/2. $135. No. How many degrees is 135 past 90? 45. So your angle starts here, and it goes 45 degrees past 90. So what we want is that theta equals 120. In order to determine this position, this xy value right here, I make, I said 120, 135 degrees. In order to determine this position, I will sketch a triangle just like that with its base on the x-axis. What is this angle right here? 45. 45, 90. So this is 1, this is negative square root of 2 over 2, right? And this would be positive square root of 2 over 2. So my xy coordinate for 135 degrees is negative square root of 2 over 2 and positive square root of 2 over 2. Yes, exactly. 150 is going to be another 30, 60, 90. Do you want to make a prediction about what values it will be? Negative square root of 3 over 2 and 1/2. Good. See, all the y values are positive so far because I'm in the first and second quadrants. What's going to happen when I enter the third quadrant? They'll both be negative. And when I get to the fourth, just the y will be negative. Now, if you go to 180, if I'm straight over on the other side, what's that coordinate going to be over there? Negative 1, 0. Are you seeing a pattern? See if you can finish it off. Okay. Or at least find the next couple. See if you can find the next couple. If you guys sketch a graph just like we did, go ahead. I'll pause the video. Okay, guys, we got 15 seconds before the bell rings. Did you get any of them? Do you see the pattern? We'll be doing the same thing all the way around, constructing 30, 60, 90s, and 45, 45, 90s all the way around. You see the relationship between positive and negatives? We pick up with that tomorrow. You will have homework tomorrow.